Hi, this is Lester Martin with Hortonworks University, and we're going to continue on in our HTTP Hadoop Essentials class. This module is called Ingesting Data. This is the rough overview objectives that we're going to run through. Just talk about ingestion as a concept, many different types of tools and approaches to loading data into HDFS. And for the most part, for the larger set of ecosystems, even though we will kind of concentrate on HDFS itself. So a variety of basic batch or bulk loading tools, and we'll definitely cover the popular streaming frameworks that are out there. And we'll finish up with a demonstration at the end. So if there's nothing else that leaves you with lots of opportunities, it's definitely ingesting data. We have classical things like command line tools such as puts or copies to, REST services that operate much the same way, an opportunity to put an NFS gateway and front Hadoop HDFS as an NFS mount point to clients. We definitely can write programs and MapReduce and other frameworks to produce and put data into HDFS. We have APIs for Java and C that you could roll your own custom solution, and we easily have some nice GUI tools for more for individuals and humans, as we saw earlier in one of the earlier modules. Definitely vendor connectors from a variety of players. These are just a few indicative examples, are an important part of integration into Hadoop. We definitely want to talk about those partners. And classic tools such as Scoop and Flume that we'll discover in a few moments have been around for a long time and are really strong players, historical players, for getting data into Hadoop. And our real-time streaming engines, Storm being a little bit more the mature of the two, but definitely Spark. Anything to do with the Spark's community, of course, is really undergoing massive amounts of innovation. And so Spark, that we'll talk about much later, has a sub framework or a additional framework around streaming. That's very popular. And then lastly, we'll finish on a technology called NiFi and a Hortonworks product called HDF, Hortonworks Data Flow. So again, there are many ways to get data into Hadoop. And we covered lots of technologies on the last slide, and we mentioned words like batch and streaming, but if you think about this we really have two primary ways that data is coming into Hadoop. Definitely, historically we focused on taking batch feeds. This may be data being created from a real-time system, but historically we would lump up that information and create a large file and push it into HDFS, and then we'd process on that with some batch engine, MapReduce, Pig, Hive, something like that. So that's still definitely going and driving many businesses, many use cases, and creating lots of insight into that data. But at the same time, we have that we're trying to look at taking advantage of the fact that we can get closer to the source of data and get closer to the timeliness of the data, and we start to introduce this notion of real-time data streams. And the frameworks that we talk about are really what I call streaming engines on this. So we're consuming data two different ways in most cases, but ultimately we're trying to produce the same kinds of things, some kinds of applications, as you see in the bottom. And both things are happening. Definitely the batch side is creating rich data that can be drilled into, etc. And definitely the streaming engines are more than likely producing some kind of alerts, maybe some high-level indicators, things like that, to let folks know how things are going. And as you see, there's a kind of a circular dependency, where the batch tools are creating characteristics that the streaming engines can leverage and make better decisions, better alerts, and definitely the streaming engines themselves are pushing information into the batch tools. It's often referred to as the Lambda architecture, if you've heard that phrase before. This kind of a batch framework, a real-time streaming framework, and then maybe a speed layer, as you see on the bottom, something that's focused on just fetching quick information displayed on some kind of console or screen. So these all coexist together. Just to kind of furthermore try to create some characteristics, some definitions and differentiations between that real time and batch. The things that probably are important here, obviously age, you get that. Speed, I think we can get that as well. We're trying to process usually in subseconds, subsecond or maybe a handful of seconds, as opposed to that handful of seconds to whatever it really takes, depending on the size of data, what we're really crunching. And maybe the clients, who is really using those systems. More than likely that we're talking about operational applications using real time, and then batch can be who it could be humans as well as these automated systems. Yeah, that covers that pretty well. So thinking about some of the technologies, obviously we saw earlier, especially in that earlier demonstration, that Embari does have this files view UI component, and I'm just kind of clicking through here to kind of see some of the call out, the balloons there that are being called out, how to upload things, move things, delete things, etc. A pretty nice user interface, especially for those that are not comfortable or even have access to a command line environment where they can make those operations themselves. So definitely Embari file view. But definitely a trusted, tried and tested and trusted tool is the old Hadoop client, HDFS, DFS, or a lot of people use Hadoop FS. And there's commands like put, copy, catalog, and those are the operations that maybe your more developer and sysadmin folks are used to and play with. But they also can be scripted and pulled together and to drive basically movement of data, etc. Things that you might do typically in your data processing workflow. Kind of a sister to the CLI as a REST service called Web HDFS, just another mechanism to get data in and out. Again, very scriptable. And I think I mentioned on the earlier slide that we can create and stand up an NFS gateways. So if you do have applications that leverage NFS today, this may be a solution for you. For the most part, it sounds right, but it's not like it depends on your application and what your application is doing today with NFS. If you're actually doing random writes into opening files and injecting a few pieces of data in the middle of the file, obviously that's not going to work well, because behind this is still HDFS, and we still have that worm, that write once, read many mindset that we discussed earlier. But definitely an option to consider. Scoop is a classic tool. It's been around a good while. It's a workhorse, I would say. Much more than 9 out of 10 clients are using Scoop, because we do have relational systems in our environment. We do need to retrieve information out of those databases, and Scoop's actually an export tool back out into in the databases themselves, and that kind of touches on that Lambda architecture I mentioned earlier, where maybe there are some scenarios where some data might make sense to push off into another system, especially if a customer is already interacting with that system. One thing, though, kind of a word of caution to consider about Scoop. Scoop runs as a map reduce job or a map only job, and we're going to talk about map reduce in the very next section, the very next module. But we're not careful. We have the opportunity with Scoop to parallelize, control the level of parallelism in its operation, but each one of these parallel or slices actually consumes a JDBC connection to our database. So we want to definitely work with our DBA team and make sure we're not going to overwhelm and overpower the database, because we can definitely run many parallel tasks in Hadoop, and in our effort to retrieve information fast, we might hurt upstream systems. So something to be careful about and be ready for. But probably just as interesting, or even a little more interesting to most people nowadays, is this notion of streaming engines, real-time data that we talked about on that first page. And all things Hadoop, you actually have a lot of options, many different opportunities to try and use different technologies. And a lot of this is based on the feature sets these frameworks have, the risk factor, that risk register that you're comfortable with it taking on, depending on the maturity of said tool. So one of the classics that's been out there for a good long time is Flume, and Flume is a full-featured streaming framework. Has many of the same hooks and bells and whistles that most other systems that we're going to discuss next produce. But truthfully, Flume is probably a little less, for folks that are starting from scratch, a little less excitable to them. There are other technologies, other frameworks in the streaming space that garnish lots more excitement today, but it's definitely, again, a tried and tested, well-oiled machine. Does what it does it well, and a lot of people are still using it in use cases where we're moving, aggregating, consolidating log files, and ultimately coalescing those back into HDFS. Definitely a good use case still for Flume even today. Probably the more mature of the other frameworks out there, are especially the ones that are a little more tightly coupled against Hadoop, is this concept called Storm. And Storm, just all these, they create workflows. They all have different names, as you saw with Flume. So in Storm, we'll use terms like spouts and bolts, and they're kind of what they say on the screen there. Spouts just bring information into a workflow, into a topology, and start pushing that information around. And bolts are our consumers, are actionable events, and usually they could be anything. They're written in Java for the most part, but other languages are acceptable. They process that data, and for our conversation right now around ingestion, what we'd like to see at the end of this workflow, or in the middle of this workflow, is a bolt to actually write that information back off into HDFS or HBase or some other Hadoop tool. But so again, they can persist data. They don't necessarily have to. Storm is not necessarily a message queue. It's not a message queue system itself, but Storm is very often coupled with a messaging system from aggregating, collecting, and letting that be the source information. So using that terminology, we would create a spout that is wired up and configured against some messaging technology, and one that we see often with Storm is Apache Kafka. It's another very popular open source Apache Software Foundation open source messaging technology that's included with HTTP, etc. So you see those coupled hand to hand, and that's a kind of a theme with many of these streaming frameworks. And in fact, I think all of them have an opportunity to bolt on to consume information from Kafka specifically. And some of them can support other queues and not other queues, but Kafka is definitely one. It's probably due to its Apache Software Foundation backbone, and definitely has itself as a tool is very popular today. So I mentioned that Spark streaming is out there today, and definitely has lots and lots of innovation. I think Spark streaming's real sweet spot, and we'll talk about Spark a little more in the future here today, is that Spark streaming lets you write Spark applications. So they look a lot like a normal Spark application. Really, it's just that we bolt on in front of the terminology we use in Spark streaming is a receiver, much like a bolt, much like a source in Flume, some mechanism that connects to some kind of data streams and then converts that into something that framework can consume and chew on. So once we get that information, then at that point, really, we just process that data just like any other data in this framework called Spark, with the subtle difference that Spark especially compared to Storm, treats Storm is processing a tuple or a row at a time all the way through that workflow, and then the Spark streaming world actually creates what we call micro batches. As you kind of see a little bit down here, if we had a stream of data and make it simple, the data is 1, 2, 3. It could be a complicated message, but we'll just make it a single integer. We're via configuration, we're controlling this size and frequency of these micro batches. But what we're showing on the screen here is something simple, like the first, 4 at a time are happening and going in there. Now, when we say micro batch, we are talking about more than likely subseconds worth of batching. So many micro batches created per second is what we're really talking about here, not spanning minutes or high order seconds and those kinds of things. And then we have another product called NiFi. I mentioned earlier. That's the open source product name, and then Hortonworks itself bundles up NiFi into a product offering called support offering called Hortonworks Dataflow. And this technology is really focused on the Internet of Things, the Internet of Everything, way out on the edge. And the intention is for data flows to be deployed further and further out of the data center or different places. This could be an oil and gas wellhead, it could be a remote military vehicle connection point where things are coming in. It could be a variety of things that are happening. It could be your car itself. And the data flow system is really looking for that extreme scale of data that we're almost always losing that level of granularity because of that. And what we're trying to do as at Hortonworks at least is couple this product offering, this suite of software called Hortonworks Dataflow, with HTTP that we've been talking about and will continue to talk about. As you see there, perishable insights, historical insights, and we feel this, the culmination of these two technology stacks together really do provide you with the most complete big data solution out there. So as you see here, just one more picture on HDF. Again, I want to imply that I want to make sure I kind of get it out there that what we're really looking at HDF to do is, sure, we can work it and use it completely in the data center, but it's definitely for, its sweetest spot is to get further out of the data center, much closer to the source of the information and be running there, configured there, and then coalescing, bringing, pushing, making insights early, and then ultimately pushing those same levels of detail back into Hadoop itself, into HTTP itself, as you kind of see here. So we lots of data that we retrieve, we load into HDF and consume it there, and then also push that stuff into full-on HTTP or Hortonworks, or Hadoop. So a quick knowledge check on this ingestion section would be, what tool would be used for importing and exporting from traditional database systems? Well, that's Apache Scoop, and maybe a couple ways we can script up just some movement, some copying of files into a variety of technologies or just simple scripts. Surely the basic CLI Hadoop client that lets us do puts and copies, that's a great one, and its kind of counterpart, the REST service called Web HDFS, would be another alternative for that. And then for NFS Gateway, the real limitation that we have here is that it is still behind the scenes Hadoop and HDFS. So we really have that write once, read many file system. So we really just, if we have an application that is trying to do some random writes into files, then it's just not going to really be a solution for us. So definitely something to investigate and make sure it's really going to work for you. Quick true-false question. How about this? The Storm operating on a microbatches. Well, we talked about microbatches, but actually we talked about them in the context of Spark streaming. Storm himself works on a tuple or a row at a time and processes it that way. And how about the most popular open source messaging technology that we package up together in this big Hadoop distribution? That is Apache Kafka. So I think we just touched on most of these points. As a quick recap of the summary. Many ways to ingest data, streaming and batch working together to make a comprehensive solution for us. Definitely the NFS Gateway could be a solution for many use cases you have in place. I think I gave the warning that we want to be careful with Scoop in our effort to consume data massively, quickly, and get it into HDFS, not to make enemies out of our good friends, the DBAs. And we walked through these four real, very complementary and sometimes overlapping technologies out there in the streaming space, from Storm and Spark and NiFi, as well as the classic Flume as well. So now we'll take a few minutes and run through a demo on this concept. We'll focus on Storm on this one. We'll load into HDFS, in Hive, and should just take us a little bit to take care of that.